39 offshore wind parks are operating around Europe's coasts. It is for offshore wind parks that TU Delft develops self-regulating wind turbines, which generate more electricity. How does a self-regulating wind turbine work? Wind is constantly changing direction. This turbulence causes the turbine rotor blades to make a dancing motion. In today's turbines, the vibrations are combated by making the rotor blades as strong as possible, but this has the disadvantage of making them relatively heavy. Turbine blades that are able to respond to the wind do not shake as much. Today's blades respond by turning completely on their axis. The angle of the blade then compensates for variations in the wind. But in very large turbine blades, the wind variations should be measured at all points of the turbine blade so that it can be regulated accordingly, comparable to the way wings of aircraft are regulated by flaps. Flaps are, however, not feasible for offshore wind turbines, as they require a great deal of maintenance. Self-regulating wind turbines produce the same effect by allowing the turbine blade to change its own shape. How does the blade do this? One solution is the use of a shape memory alloy. Electrical currents heat the material and change the shape of the blade. When the material cools, the blade bends back. The memory material movements are directed by control engineering. A LIDAR device in the nose of the turbine measures variations in the wind's strength and direction. Sensors in the blades measure how the blade responds to these forces. The information is transmitted to a chip, which determines the ideal blade shape to ensure maximum stability. The electrical currents enable the blades to adapt. The aerodynamics of the blades is vital. After all, a different blade shape influences the wind variations, which in turn influence the blade shape. By using these stable turbine blades, we can reduce the wind load by almost a third. This means that turbine blades no longer need to be as strong or as heavy. That makes them cheaper to produce. Another option is to make the blades 10% longer, enabling the turbines to generate more energy. In their work on the self-regulating wind turbine, researchers at TU Delft are improving the efficiency of offshore wind parks.